Good morning. I wanted to talk a little bit about what we did at the close of last class before we move on to the next unit. We were talking about the distinction between concrete entities and abstract entities, and then I was going to talk about alternative schemes of ontological classification. So first, the distinction between concrete things or concrete entities and abstract entities. Usually that's spelled out in terms of the notion that concrete things have a location in space and time, and abstract things are outside of space and time. Or alternatively, that concrete things are in either space or in time, and abstract things are altogether outside of space and time. That's not too bad as a first approximation. It gets most of the cases, but it doesn't seem to work for all of them, and there are some problematic cases, as I mentioned. One case has to do with spiritual beings or souls, which seem to be not abstract entities like numbers or properties or propositions or relations. They seem to be concrete, substantial entities, though not material entities. The problem is that they're outside of space, according to Descartes and most views of spiritual entities like God, for example, or an angel or a demon. They're not spatially located, or not by their nature spatially located, even if they could manifest themselves somehow in spatial reality, like God could appear to Moses as a burning bush or whatever. Still, God isn't actually located in his nature or essence in space, not made of any kind of spatial substance. So it looks like we can't say that being in space is required for concreteness. What about being in time? So you could say being in either space or in time. There too, traditionally, Orthodox theology has held that God is also outside of time as well. That might be wrong, though, but it still seems conceivable that one could imagine some kind of spiritual being that doesn't exist in time, one that doesn't engage in any kinds of actions, for example. So it's if something raises doubts about God actually being outside of time, it's mainly the fact that God does things, seems to then make God a temporal being by virtue of performing actions which are events and so forth. So one could imagine a spiritual being that's not engaged in any kinds of actions. Maybe it just contemplates eternal mathematical truths. And since those truths themselves never change, like 1 and 1 equals 2, 2 and 2 equals 4, imagine the being is mathematically omniscient. It knows all and only mathematical propositions, or all and only necessary truths that never can change. Imagine that being necessarily exists itself, so it knows that it exists, and it knows all the necessary truths of logic and math. And none of that ever changes. It doesn't seem like a being like that needs to necessarily be temporally located. It just sort of thinks about everything all at once, and there's never any kind of change in its thought processes. It just sort of meditates on all the necessary truths. Seems like it might be a concrete being that's outside of space and time. You might say that's a stretch. Okay, but even so, we have the problem on the other side is that some abstract entities may be in time. why couldn't some abstract entities stand in some kinds of temporal relations to concrete entities? So one thing that abstract entities can't do is change in themselves, that is, undergo inherent or intrinsic change, like the number 7, or the property of being a triangle. These abstract objects, the number 7 and triangularity, clearly would never undergo any internal change. By an internal change, I mean the kind of change, say, that a piece of wax undergoes when it melts. That's an intrinsic change, as opposed to a relational change, the kind of change that a thing may be said to undergo when it changes its relationships to other things, even though it itself doesn't change. So imagine a basketball that moves from one spot to another. The basketball doesn't undergo in itself any change. It doesn't lose any air or changes color or anything like that. But at one time it was, say, near that chair, near that desk, and another time where it rolls over, it's much closer to, say, that desk over there. So the basketball has undergone what's called a relational change. So when we think of an abstract entity undergoing a relational change, that seems like a feasible proposition. Triangularity, for example, might be exemplified by a certain triangular object at one time, like a piece of wax, and then the piece of wax melts, and triangularity is no longer exemplified, right, by that piece of wax. So it seems like over time, the relation between the abstract entity triangularity and the piece of wax, which was triangular but no longer is, changes. Now, why shouldn't that suffice for a temporal relationship? It's not, it seems like it does. I mean, normally we understand the idea of time as a relational affair. I mean, if we think of what's required for time, we think that you need to have some kind of change, but the change doesn't have to be intrinsic. It could be like the Earth rotating around the sun or something, right? Would set up a temporal system. Neither the sun nor the Earth in themselves have to necessarily change, so long as you have the rotation, right? So it seems like all you need for something to be in time is relational change, and it looks like abstract entities can undergo relational changes. Another example would be that Mary might be thinking, say, of the empty set at a certain time, and not be thinking of the empty set at, say, some other time. And that would appear to be a relational change between Mary and the empty set, that she's thinking of it one time and at the other. I'm not claiming it's a change in the empty set. The empty set doesn't in itself change, but it changes or shifts its relationships to Mary. And then it seems like we can say that at a certain time she's thinking of it and at a certain time she's not. So wouldn't that mean that the empty set was in time? And the empty set surely an abstract entity. Furthermore, another kind of example would be if you hold a belief that some abstract entities are immanent in the world. This is the kind of view that Aristotle held. Remember, Aristotle said that properties are a kind of entity that, like dogness or catness, exist, but only insofar as things have them. So that if a certain species, say like dog, or the property had by the members of that species, canininity or dogness, could come into existence when dogs came into existence. But if dogs went out of existence due to, say, some horrible plague that wiped out all the dogs, then dogness would go out of existence. But that would seem to make dogness a entity that's in time as well. that argument wouldn't apply if you think that all of these properties just eternally always necessarily exist. Then you'd have to rely on that other argument, the first one that I gave, to suggest or imply that some abstract entities are in time. But if they are, then we can't say that being in time is a necessary, we can't say then that being outside of time is required for an entity to be abstract. And again, our account of the abstract concrete distinction in terms of concrete entities being in either space or time and abstract entities being in neither space nor time is not going to work. So that's why I developed this definition of the concrete abstract distinction in terms of what are known as the level C categories. So intuitively, the idea is if you have a bunch of categories picked out, say just like these, I mean, these are enough. We could make the list longer, but just say you start with that list and you just give it a name, L. The basic intuitive idea is that a level C category is a category that is of the level of generality that the categories on L have. So it's a peer category in terms of how general it is. So it's not more general than those, but it's not more specific either than those. That's the basic idea. That can be actually formally defined, which I briefly went through last time. We'll reiterate. But given that intuitive idea, anyway, just sort of the intuition that here we have a group or list of categories that are peers to one another and are at the same level of generality, substance, event, boundary, property, relation, proposition. So each is a particular variety of entity that you might believe in metaphysically. And that's the basic idea. So a concrete entity is one that's an instance of a level C category, such that that category could have examples or instances that have spatial or temporal parts. Right, so take a substance. The category of substance could have some cases that have spatial parts, for sure, like a table. Okay, God may not have spatial parts, but God falls under that same category as a table. God's a substance, just like the table is a substance. So by belonging to the same category, God is judged to be a concrete entity on this, even if God is totally outside of space and time, because it belongs to a level C category that can have at least one instance that has spatial parts. So it's the company you keep within a category that determines where you fall in the abstract concrete distinction. This definition is flexible enough then to allow for a sort of unusual or marginal cases of the category that fail to have some of the characteristics you would expect in most entities of that category. Most substances are in space, but there may be some curious ones like spirits or souls or angels or gods or divine beings of some sort, like Aristotle's prime mover, say also, which just thinks about thinking all the time, and by his example moves the universe as a final cause. Those entities don't have to have spatial or temporal parts necessarily. They can still meet the definition. If you recall from last time, there was also an issue with places and times. Are they themselves located in space or time? It doesn't seem like a space is in another space, nor can we really say that it's in it, that it occupies itself. That seems to be just a conflation of occupying a space with being identical with a space. Yes, every space is a space, but that doesn't mean it occupies itself in the way that, say, an apple would occupy the space. It just is a space. But then, if we were to say that it's in space, we'd be confusing the relation of being the same entity as, which is identity, with the idea of occupying a space, which is a completely different relation. So it looks like there's a problem with saying that spaces, which are, by definition, concrete, insubstantial kinds of beings, that these entities, although concrete, don't occupy space themselves. And there may be similar problems with times as well. Doesn't seem like we can say that times can occupy times for the same parallel kinds of reasons, unless we have an infinite regress of meta-times, which seems ridiculous. Don't have a problem, though, if we use this approach, right? Because place and time would be at the same level of generality, right, as these other categories that we have. And they do possibly have instances that either have spatial or temporal parts. Places possibly have other places as parts, right, which would be spatial parts. And times, obviously, would have possibly have other times, like a day has hours as parts. And those would be temporal parts of bigger time. So they would meet the definition as well. Now, what about other categories that aren't on our initial list here? Well, we could just accept intuitively that they're at the same level of generality as these. Or we could actually define it in terms of the species-genus relation, which I talked about last time. So we could say that a category is at level C if it's one of these ones we have here, right? Or if it's not one of these, first of all, it's not a species or a genus of any of these. Okay. Nor is it a species of some other category that's not a species or a genus of any of these. Some other category that's not on our list. You could imagine that there are other categories not on the list, like set, right? So take the category of sets, it's not on our list. Why is set at level C? Well, intuitively, it's another one of these kinds of categories. But beyond that, it's not a species or genus of any of these, nor is it a species of some other category, not on the list, that's not a species or genus of one of these. So it would be at level C as well. So it's interesting that by using categories, we can actually solve certain philosophical problems, like what's the distinction between concrete and abstract entities, which is an interesting result. So categories may have usefulness not just because they help us organize what exists or might exist, possibly exist, in the universe, but also because they may help us solve certain metaphysical problems of definition or analysis, of how to define the difference between abstract and concrete. Later on in the course, we'll see that they're also useful in helping to define the concept of substance, what it is to be a substance. Okay, so what are some alternative schemes? All right, so we've seen one scheme of classification is based on this abstract concrete distinction. So it starts out with the highest genus, say being or entity, and then we break it up into the two big kingdoms of concrete beings or concrete entities and abstract entities. And then we further divide these up into the different kinds of concretes and the different kinds of abstracts, right? And so on. until the categories or kinds become too specific to really be of interest to metaphysicians anymore. Like we wouldn't want to say that cat is an ontological category, or even animal, I don't think, right? Let alone say like a purple house or something like that. So they have to be pretty general, high up there in the level of generalization. So that's one way we could go. That's the system that I've favored, just on pragmatic grounds. It seems to help solve a lot of problems in metaphysics. But there are other ways to go. Another way to go is to take as your primary, and we call that sort of the first division. So you could have a different first division there. And remember also that we're just looking at provisional systems here that include sort of candidate entities. And we recognize that later on we may be able to eliminate or reduce some of these categories to other ones. And that's certainly fair game. Yeah?
Can you say that again? Provisional systems that include what?
Yeah, these systems of metaphysical or ontological categorization are provisional in that it's not being stated when you lay out these systems that all of these entities are ultimately going to be recognized as actually existing. You may be able to simplify the system. For example, say that times can be fully explained, say, in terms of events. So then we could reduce talk about times to talk about events, and then we'd have a simpler system. So we might just believe in a system that had substances, properties, and events. So that would be one system. And maybe you could explain everything just in terms of those three. But our common sense or folk theory of the world, we talk about many more things than just substances, events, and properties. We also have lots of other things like sets and numbers and relations and places and so on and so forth. So, but we don't really know in advance of doing metaphysics where it's all going to wind up. Like what the best system is. That's a huge enterprise, and there are innumerable controversies and problems. It's not clear what the minimal ontology is. That is the minimal number of beings that you need. And there are wildly different theories. Some philosophers believe that only concrete entities are needed. Others believe that only abstract entities are needed. Some believe that you need some abstracts and some concretes, but which ones exactly they disagree on, and so on, right? So you could still lay out all the possibilities and say, here's how we can organize them all. And then later on try to figure out what the simplest system is. Occam's razor says that ultimately we should favor the simplest system, all other things being equal. Given that two competing systems can explain the same data, we should pick the simpler of the most economical of the two, the one that posits the fewest basic kinds of entities. So there are different ways that can shake out. One process is ontological elimination, and another is known as ontological reduction. Elimination occurs when you say that a certain kind of entity that we talked about to begin with actually doesn't exist at all. We can eliminate it in favor of something else. So a view like that might be that we can eliminate times in favor of events, show that times don't really have any ontological status at all. They don't exist. So we can just cross them off altogether. Instead, we'll talk about events and explain everything in terms of the way that certain events are related to one another. So that would be one kind of result that we might have when we eliminate an entity. show that it's actually not needed, and therefore, and conclude based on that that it's unreal, that it doesn't actually exist. Another example would be a philosopher who would argue that all these compound entities that we see around us, that is, things that have parts, can actually be eliminated, and that they don't actually exist, like tables and molecules and atoms and so on. The only things that exist, according to these philosophers, are the indivisible particles. So they would eliminate all compounds in favor of indivisible, simple objects, like electrons and photons. So they would say the only things that really exist are the basic particles. Of course, if we said that in general, we'd be materialists who only believe in material things. But we might say that we might say those are the only concrete things, and in addition, you need some abstract things. But there have been strict materialists who only accept material or corporeal substances, and among those, only accept simple ones, claiming that that's the simplest or most economical theory. It just recognizes basic particles as existing. So these are all examples of elimination. So you eliminate an entity in favor of some other related entity. So we don't really need to take seriously these compound entities. If we're really being serious, it's only the basic ones that exist. I'm not endorsing that. I'm just giving examples of possible views. So that's ontological elimination. A famous example that was given is that once upon a time people believed in witchcraft, and they thought that there were witches, like in Salem, Massachusetts, where people were burned at the stake because they were judged to be witches. If we decided that witches don't exist, and that witches are just sort of what were thought to be witches were actually just some peculiar people, or maybe people that had certain mental problems or whatever, then we'd be eliminating witches from our ontology, so that they don't actually exist. In contrast with that, there's a process known as ontological reduction. Ontological reduction doesn't eliminate the entity. It admits that it exists, but it just says that it's actually a species or kind of some other kind of entity. So on that view, if one held that times exist, but they can be reduced to events, then you'd be saying, well, times exist, but they're actually a species of changes or events. A famous example of ontological reduction is lightning. You've all seen during storms, like big flashes of lightning in the sky. We can show that lightning is actually an event, right? It's a flow of electrically charged particles. So we could reduce lightning to a flow of electrically charged particles. Then we wouldn't be saying that lightning doesn't exist, right? We'd say lightning does exist, but it's a species of event. It's not a separate category all unto itself. Right? It's a kind of some more general type of thing, but it does exist. So then you'd be saying that every instance of lightning is actually identical with a particular flow of electrically charged particles. So both those kinds of arguments or moves can change the way your classification system, right? By placing a certain category, say, that was initially thought to be at a certain level, right? Moving it down to a lower level. Just becomes still exists, but it now becomes a species of something else. Famously, it was argued that numbers turn out to be what? A kind of a species of sets. So then numbers get demoted from being level C categories to being like level D or something like that. But they still exist. Or you could hold that numbers don't really exist at all, eliminate them. So that would be a difficult thing to do, since they seem so useful. But there are some who eliminate numbers, but others try to reduce them to things of other kinds. So it's good to keep in mind that distinction between ontological elimination, which is just getting rid of an entity altogether, versus ontological reduction, which is showing that it's actually a special case of some other kind of entity, which always results in moving it down to a lower level in your classification system. It becomes a species of some other entity that's more fundamental than it is. Makes sense. So anyway, so here's one way to go. Another system, though, would divide up entities into two different families called universals and particulars. It's kind of similar to this one, right? But it's not exactly the same. What is a universal? A universal is something that can be had by many things. It can be predicated or said of many. More precisely, in this context, it's something that is capable of multiple instantiation. Well, we've already talked about some examples like dogness and catness and so on. So a universal is an entity capable of multiple instantiation, or of having multiple instances, like dogness, Rover, Fido, and Spot would be the multiple instances. So they would have to be capable of having at least two instances of the thing. So dogness and catness, felininity and canininity would be universals. A particular, on the other hand, is something which is not a universal. So it's not capable of having multiple instances. And examples of that would be Morris the cat and Fido. So they'd be particulars. So you can see that universals are a kind of abstract thing if you go between the two systems. And particulars tend to be generally concrete things, but maybe not all of them. Take sets, for example. Sets turn out to be, although abstract entities, to be particulars. Because a set can't have multiple instances, like the empty set doesn't have any. It wouldn't be the empty set would not be a universal because there aren't many things which exemplify the empty set. There isn't even one. So it's not the same distinction as that distinction over there. So sets would turn out to be under the category of what? Universals or particulars. They'd be particulars, yeah. So really the only thing that would go under here are these general properties and relations, like betweenness and canininity and so on. And everything else would be over on this side. So you could break this up into different kinds of universals. I guess there's only two, right? Properties and relations. And I guess you could break these down into further, right? Different kinds of properties, right? Like maybe physical properties and mental properties, different kinds of relations, physical relations and mental relations, or whatever. And under particulars, you'd have all these different kinds of things, so maybe substances, events, so on. Boundaries, whatever. Sets, propositions, right? It seems would fall under that too. They're not universals. At least they don't seem to be. Unless you say that some propositions can have multiple instances somehow. Some kind of view that said, say, that the proposition, it is raining, has multiple instances. It's instantiated, say, by different concrete different particular events, say, of raining in different places or something like that. Like the rain that's occurring in this city and the rain that's occurring in that city are both instances of it is raining. Try to turn propositions into universals. But that would be a highly controversial view, but it's a possible view. Generally, it's held that propositions aren't exemplified by anything. So they'd be particulars. So, and then under here you'd have different types of substances like bodies and souls, and so on and so forth. So that's another system. I really know of only one other system that's gained any currency in addition to these two. So that one says that entities can be broken up into two kinds of beings known as necessary beings and contingent beings. Those are two. And this is going to take us into the topic of modality, which is our next topic. Because necessary and contingent are examples of modal, of modalities or modal, represented by modal prefixes or terms or relations. So I'll have more to say about that, but so here's what we'd have. We'd have entities that break up into necessary and contingent ones. So under this, you'd have, say, necessary substances would be on this side, and I guess contingent substances would be on that side. So what is a necessary being? A necessary being is one that has absolute necessary existence. In other words, it's impossible for it to fail to exist. So it's not capable of being either created or destroyed in an absolute sense. It's impossible. In the way that it's impossible that a round square exists, it's impossible that a given necessary being fail to exist. One traditional example is God. So it's thought that if a God exists, then God would have the attribute of necessary existence and would be a necessary being. Another way of putting it is that there's no possible world in which the being fails to exist. In no universe that's at all possible would that being fail to exist if it's a necessary being. Contingent beings, on the other hand, exist but could fail to exist or would fail to exist under some possible set of circumstances. Generally, they're subject both to creation and destruction, in theory. Generally, things get created or destroyed through assembly or disassembly. Like you can create a table by attaching the parts to each other. So by assembling certain things, you create a table or a living creature, right? A living creature is assembled according to hereditary genetic blueprint of its DNA, which, right, when it's born, it starts to grow and it gradually builds itself up, right, very miraculously. So that's a form of creation by assembly. And then on death, it disassembles, it starts falling apart. Right? It can't continue to maintain itself anymore in the case of the living thing. And eventually it crumbles away, right? And dissolves. Or disassociates until it turns into dust. Or whatever. All that remains are the particles that composed it originally. Similarly, we can disassemble the table. It may exist now, but if we chop it up, then it'll fail to exist. At some point, things that exist get worn down and cease to exist. Of course, the fundamental particles, right? When we're talking about the view that says only the fundamental particles exist, they're not capable of destruction by assembly or disassembly. Would that make them necessary beings? Or could there be other ways that a thing could be created or destroyed that would not involve either assembly or disassembly? Perhaps, right? Traditionally, that kind of creation or destruction is known as creation ex nihilo. It's creation from nothing, since it's not creation from any kinds of parts. And similarly, destruction in nihilum, destruction into nothing with nothing remaining. There might be something in between creation by, or destruction by assembly or disassembly, and creation ex nihilo or destruction in nihilum. That would be where a thing is created or destroyed, not by assembling or disassembling parts, but by turning the thing into something of a wholly different nature. And it seems like that does happen, even with what are known as the fundamental particles. So the answer seems to be to our original question that fundamental particles don't necessarily exist, because they can cease to exist. Like if an electron meets an anti-electron, so for every piece of matter, there's a current. Every basic material particle, there's an antiparticle. So for the electron, which has a negative charge, there's the positron, which has a positive charge. And if the two ever meet, there's a big explosion, or actually it's a very little explosion. But it releases a lot of energy relative to the particles. If you had a big piece of antimatter and another big piece of matter and put them together, you'd have like a super hydrogen bomb that would go off if you had big pieces. When they're tiny little particles, you don't notice. Still a lot of energy being released. So they both get annihilated and some other particles come into being, like photons or something, which are also fundamental particles. So it doesn't seem like electrons could be made of the photons or anything like that. It's just a transformation, fundamental transformation. So through fundamental transformation, particles can go out of existence and other particles can come into existence. It's also thought that in physics that all the time particles are just coming into existence out of the vacuum that they call the quantum vacuum. They just pop into existence. The thing is, they don't last very long. So they're called virtual particles because they last for an inconceivably short amount of time. But they still apparently do exist. They're continually coming into existence and then going out of existence. I guess they go out of existence because they collide with antiparticles and then they annihilate each other. So they don't last very long. Is that an example of coming into existence ex nihilo? Not clear. There's a lot of dispute about that. Some say they come into being out of this quantum vacuum, and the quantum vacuum is not nothing, it's something. So maybe it's creating them. Or maybe they just come into being out of nothing. We don't really know. Since the status of all these physical theories is rather obscure. But they have been measured. I mean, you can actually see the effect of these particles coming into being. It's measurable. You might think it violates the law of conservation of energy, which says that nothing can be, essentially that nothing can be created or destroyed. That the total amount of mass/energy in the universe is constant, unless stuff comes in from some other universe or something. Right? Like if you believe that there are other universes that could leak stuff into our universe, so to speak. Of course, if by universe you mean everything, which is a perfectly legitimate meaning of universe, then of course that's contradictory. The universe would just be the sum of everything, including all these universes. But if by universe you mean a kind of autonomous spatiotemporal domain, which is relatively or completely separate from other such domains, then I guess it opens up the possibility of stuff coming in from other dimensions or universes into ours. So, but the reason anyway that these particles don't violate conservation of energy has to do with certain basic quantum mechanical principles relating to what's called the uncertainty principle. And the uncertainty principle says that, well, what it says is that you can't ever measure the exact position and velocity, say, of an electron, of a single electron, and that actually it doesn't even have any precise value. You can say that there is a precise value for its velocity, but it has no exact position, or you can say it has an exact position but no exact speed. But you can't say it's got both at the same time. And what that means is that the amount of energy in the universe is actually indeterminate. There's no exact figure for what that is. And that's how these particles can go in and out of existence. They last for such a short amount of time that they fall within the uncertainties. So they don't violate the conservation of energy rule. So modern physics is quite strange. So anyhow, why were we digressing into this? Just to bring out the point that fundamental particles don't seem to be necessary beings. God would be a necessary being, but not these basic particles, since they seem subject to all kinds of odd processes whereby they could come into being or go out of being. And that's what modern science tells us about these things. That's not in dispute. What is in dispute is exactly how this works, but it's not in dispute that these entities are subject to creation and annihilation. That's a consequence of all our best scientific theories in physics. So fundamental particles won't be necessary beings, but God might be one of these necessary substances. Hard to say what other necessary beings there could be. Maybe some abstract entities, like the proposition that 2 and 2 equals 4. Mm-hmm. So propositions, especially necessary propositions. So a necessary proposition is a proposition that must be true For example, the proposition that either it is raining or not, or the proposition that no spherical cubes exist. So that would be that proposition is true no matter what. No matter what, it's going to be true that no spherical cubes exist, because a spherical cube would be an impossible entity, an entity that's a sphere and also a cube simultaneously. And you can see that spheres and cubes have incompatible characteristics, like being round and being flat-sided. So no spherical cubes exist is an example of a necessary proposition that must be true. So it seems like it's got to exist necessarily if it's going to be true all the time. It might imply the existence of other necessary beings, like properties. Like, seems not a huge stretch then to say that if there's this necessary proposition, then there would also be sphericity and cubicity, and that they would have to exist too. But that would be a further step. One might defend it by saying, well, sphericity and cubicity are constituents or parts of the proposition that no spherical cubes exist. But that would be a further ontological move one would have to argue for. So you'd have necessary beings and different kinds of necessary beings. And then under contingent beings, you'd have all the beings that are subject to creation and destruction, like substances, events, and so forth. You could keep on going. Whatever. And it seems like with these three systems that you could work it so that you could classify all the same objects, whichever one you pick. So really, I think the issue would have to be decided by which system is the most useful for a given purpose. I don't think you necessarily have to reject any one of these three systems. I mean, you can. All that's at stake here is classification, and there can be more than one way to classify the objects in a given domain. This is kind of analogous to what we find in logic and mathematics when it comes to axiom systems. A given system of mathematics or logic could have different axiomatizations of itself. So we could construct, say, propositional logic based on one set of axioms or a different set of axioms or a third set. All these sets of axioms turn out to be equivalent for the purposes of deriving the truths or theorems of the system. So here too we could use these different schemes. Wind up classifying all of the very same entities. Each would find a place, whether we divide them up into abstract and concrete, or universals and particulars, or necessary and contingent. We'll wind up being able to make a box or a kind or a category for all the same beings, either actual beings or possible beings, whichever system we pick. The more substantive question is, among actual beings, then, what's going to be your final ontology? But that's too big a question for us to try to settle at the outset. Though I would say that the basic data that we have to take into account is provided by our common sense beliefs, and then by our scientific theories that themselves try to explain the character of the world. based on those, again, those common sense beliefs. And we may have to give up some of the common sense beliefs along the way. The trick is to try to do is at least the minimal amount of violence to them that we can, though, I think. Sometimes things have to be given up. So a naive person might think that an object like a table is completely dense and solid and has no motion in it whatsoever, but science teaches us that it's actually the parts of it, the electrons and molecules, are constantly whirling around. So we don't see any of that, right? So at a certain point, we have to revise our belief system. Primitive people thought that the Earth was flat, because when they looked out, right, the Earth looked flat to them. But it turned out the Earth was a sphere. Maybe they would even have trouble conceiving how the Earth could be a sphere, right? Because they'd say, well, then some people would be like hanging upside down. The people who lived in the southern hemisphere would be like hanging upside down. Right? And so they'd say it's absurd to believe that the Earth, but yet we've discovered that the Earth is a sphere and that being upright is relative, right? It's relative to the gravity that's holding you down, and if in the southern hemisphere you feel like you're just as much standing up as you do when you're in the northern hemisphere, even though each in relation to the other, you'd be upside down. It's just a mistake to think that being upright has anything to do with the absolute direction in which one's head is pointed. It has to do with a more complicated relational situation, the relation of one's feet to the center of gravity of the Earth. So common sense beliefs should be given up when they're shown to come into conflict with other common sense beliefs. And that can be shown very often by explanatory theories in science or in metaphysics, which show that something's got to be given up because of a conflict. All right, so let's move on then, if there aren't any questions about this, to the next topic, which we've already touched on, which, if you look in your syllabus, is modality. Modality covers a number of different things. One of the types of modality are known as logical modalities, and these include necessity and contingency. So there are examples of modes that apply to, in this example, propositions. So one of the most important modalities are the logical modalities. There are four main logical modalities: necessity, contingency, impossibility, all of which have been mentioned today, and possibility. So those are the four main logical modalities: possibility, impossibility, necessity, and contingency. It's possible to define these in terms of each other, but ultimately you're going to be stuck with one of these modalities, one of these logical modalities being taken as undefined. So if you take possibility as your primitive or undefined logical modality, the expressed by the prefix, it is possible that. Like, it is possible that there are unicorns roaming the plains of Nebraska. So, right. Possible, though not actual, right? There aren't actually unicorns roaming plains of Nebraska, but it is possible, right? Maybe there was a secret nuclear test and some radioactive grass was created and some wild horses grazed on the radioactive grass and mutated and grew horns out of the mutant. Horses grew single horns out of the center of their heads, right? So it is possible, right? That would be the naturalistic explanation of how it's possible that there are unicorns roaming the plains of Nebraska. There's also a supernaturalistic possible explanation, which is that God created all the animals, right, as told in Genesis, and if he created weird animals like elephants and ostriches, he could have also made unicorns. So it's possible that at creation, God would create unicorns and dragons and all kinds of beasts. God just didn't do that. Or maybe on other planets these creatures evolved, which would then be, could be either a naturalistic explanation or a divine story, that God created them on these other planets, or they just evolved through natural selection and processes of evolution. And they could land here in a spaceship and be in Nebraska and so on. So you could tell a story about how all these things are possible. So given possibility as a modality of propositions, remember, and how can we define a proposition? Can anyone define what a proposition is? Must be either true or false. Excellent. So the proposal was that a proposition is something that is either true or false in basic sense. So it has a truth value. So if we take possibility here as a modality or mode of propositions, and we just take that as an undefined thing, but we can give examples of it, like it's possible that there are unicorns roaming the plains of Nebraska. It's possible that instead of coming to class today, you stayed home because of the icy roads, right? And so on. And of course, anything that's actual is possible as well. So it's possible that there are 4 people in this room now, because there are 4 people in the room now. So given possibility, we can then define impossibility. So we can say P is impossible, a proposition P is impossible if and only if, IFF, it is false that P is possible. Right? So if we take possible as our basic concept, we can define something to be impossible if it's false that it is possible. That makes sense? So I guess we should write it like this. Which then says squiggle, which means it is false that. It's a negation symbol. It is false that P is possible. That would make P impossible. And if P is impossible, it's false that P is possible, so they're equivalent. All right. What about a proposition being contingent? Okay. A proposition is contingent when it's possible for it to be true and it's possible for it to be false. So there are unicorns roaming the plains of Nebraska would be possible and also contingent, because it's possible to be true and possible to be untrue. So P is contingent if and only if P is possible and it is false that P is possible. Any question about that one? So Donald Trump is the next president of the United States would be possible and also contingent, but not impossible. Right? Okay, so what do we have left? Possible, impossible, contingent. Necessary, right? P is necessarily true. P is necessary if and only if it is false it's false that possibly not P. It is false that it's possible that P is false. So P is necessarily true if and only if it's false that it is possible that P is false, right? So take 2 plus 2 equals 4. That's necessarily true. So it's false that it's possible that 2 plus 2 is not 4. Right, and that'll always work for any necessary truth. So given possibility, you can define the other logical modal characteristics of propositions. These are known as, a fancy word for these logical modalities are alethic modalities with an A. A-L-E-T-H-I-C, alethic modalities. Or you can just say logical modalities. It means the same thing. Okay, in addition to these alethic modalities or logical modalities, there are also doxastic modalities. Doxa is the Greek word. A lot of philosophical terminology comes from Greek or from Latin, though the Greeks were the first philosophers in our tradition. So doxa refers to beliefs. So doxastic modalities are modalities that have to do with beliefs and with other so-called propositional attitudes, psychological attitudes, other than, for example, psychological attitudes other than belief, which are analogous to belief. The analogy is that they all take propositional objects. So we can believe things like propositions. If you say there are a number of things that Tom believes, and you might give a list of propositions that he believes. He believes these things and he disbelieves these other things. So belief and disbelief are modalities then, but they're not logical modalities. They're doxastic modalities. They're modes that propositions take in relation to psychological attitudes like belief or disbelief. What are some other things that we can do other than believe a proposition? We could hope for it. Like somebody might hope that Bernie Sanders will be the next president. Right? So then the proposition that Bernie Sanders is the next president is the object of the hope or the wish or the desire. So propositions then can be modified, right, or be the objects of these psychological modes: belief, desire, hoping, wishing. What are some other examples? Fearing, right? I fear that Ted Cruz will be the next president, for example. One might harbor such fears, or one might want Ted Cruz to be the next president, in which case that would also be an example of, right, desiring or wanting some proposition to obtain or to be true, right? So belief, desire, hope, fear, all of these types of things, doubt, all of these can be directed upon propositions and constitute a different kind of mode or modality. Though it's not the same as the logical modality, obviously. Saying that somebody believes that 2 and 2 is 4 is nothing like saying that it's necessarily true that 2 and 2 is 4. The similarity is just that in each case we have a modification or mode that applies to a proposition of a very different sort in the two cases. Some people speak of temporal modalities. So these would be modalities of propositions that have to do with time. So what would be an example of that? That this proposition, it is snowing, so, right, is future, present, or past. So, right. So while it was snowing, we could say presently, right, it is snowing. So we'd have the proposition it is snowing, and in front of it would be presently. So that would be a modality of that proposition. Or if it's in the future, like the day before it snowed, we could say, right, it will be the case that, or in the future, it will be snowing. And similarly, after the snowstorm, we could say it was the case that, or earlier, right, it was snowing. So earlier would be a, or in the past, or earlier would be a modality of a proposition, it is snowing in that case. So those would be temporal modalities. So we could distinguish temporal, doxastic, and logical modalities, and there may be others. Trying to think of some other one. Let's see. Yeah, there are epistemic and deontic modalities. So an epistemic modality would be a modality that relates to the level of confirmation or knowledge or certainty. So you could say it is evident that it is raining, or it is acceptable that it's raining, or it is unacceptable that it's right. So those would be epistemic modalities that would relate to the degree of evidence for or against a proposition. And what was the other example? Yeah, deontic modalities. Those have to do with morality. So if you have a proposition or that ought to be the case, you might say it ought to be the case that everybody is happy. So that would be the proposition everybody is happy. The modality of it would be that it ought to be that everybody is happy. Right? Or it ought not to be that everybody is in pain. Right? That ought not to be the case, that everybody is in pain. So those would be deontic modalities. Some systems say there are three basic, that there are three notable deontic modalities. What is required, what is permitted, and what would the third one be? Required, permitted, and forbidden or prohibited. And each of those could apply to a proposition-like entity. Say that a certain state of affairs or proposition is required. That one ought not to kill is required. It's prohibited that one steals, that one steals something is prohibited, and some things are permitted but not required, like my having vanilla ice cream for lunch or something, right? So that would be allowable but not required for me to do so. So there are all these different kinds of modalities that can apply to propositions. So for next time, I want to start off with an important distinction that applies to these modalities. It's covered in the reading. It has to do with the distinction between de dicto and de re attributions of modalities. The difference between saying, for example, that the number of continents is necessarily odd. So how many continents are there? 7, which is necessarily an odd number. And saying that necessarily the number of continents is odd. Because obviously there could have been more continents or fewer continents. So one kind of attribution known as the de dicto attribution of necessity applies to the proposition that that there are 7 continents. The other applies to the entity referred to by the description, the number of continents, which is the number 7, and says that it's necessarily odd. So de re attributions go to the thing, and de dicto attributions of the modality go to the proposition. We find a similar thing with belief as well, as we shall see next time. Also, I want to remind you that the first 4 to 7 page paper is coming up on February 2nd. So if anyone wants to consult with me on that, today would be a good time to do that. Feel free to email me or contact me by Skype or whatever if you can't make my office hours. Okay, so I'll see you all next time.